Okay. Sorry for the delayed start. I just wanted to get screen capture going. So, welcome to day 2 of Robot Systems Programming. Today, we're going to spend hopefully not more than half an hour. I'm going to hit the high points of the tutorials and the assignments that I want you to do this week. And then we'll have a clinic where you can just work on stuff. And I'll be available to answer your questions. I'll kind of wander around. And if anybody needs any help, I can help you out. Any questions or concerns or problems that you've experienced so far in the course? Yes. So, on your website, you say that on the lines you Tuesday, February 7th, which is actually Wednesday. Sorry. So yeah, I'll fix that. I just wrote that. Okay, so it's actually Tuesday. Yeah, Tuesday. Yeah. So what seemed to work well last year and the year before was having the homework assignments. I'll correct the typo. Homework assignments are due on Tuesday at the beginning of class every week. And the rationale for that, and we'll have 3 or 4 office hours, but 1 on Friday, at least 1 on Monday, at least 1 on Tuesday, to help you out with any problems that you're having. And my experience was that office hours immediately after things were handed in weren't heavily utilized, and that starting around, if something due Tuesday, starting around panic would set in sometimes on Friday, and definitely by Monday. And so we wanted to schedule the office hours. And I scheduled myself on Friday afternoon. Sohem is at 1 p.m. on Monday, and Tyler is going to be any time on Tuesday. And so, how many folks would prefer for Tyler to have him in the morning on Tuesday, as opposed to the afternoon? Morning? Afternoon? Okay. It's like the mornings are slightly winning out. If none of our office hours work for you, then see me, and one of us will see you individually. Just drop us an email and make sure that all 3 of us get it. Make sure, as I said in the email that I pushed out to you a couple of days ago, if you send me an email, I get like 200 emails a day. That's not good in the spam. The spam filter is pretty good, and so it's insane getting through them. I hate email. But if you put 53707 Robot Systems Programming in the subject line once a day, I search for that. And once a day I also search for advising, so I can find my advisees' emails in this morass of email. So if you put 53707 Robot Systems Programming, there's a good chance that I will respond to your email within 12 hours. If you don't, I might not see it. So I'll correct the typo on the assignments. Some students ask, I realized I had to put it on the website, how is the course grade computed? There's no exams. This is a project-based course, and there will be 6 or 7 weekly assignments that will finish either the week before spring break or run into the week immediately after spring break. And the rest of the semester will be an independent project. We looked at some videos of a couple of projects last time, and if you go to that YouTube channel, if you go to YouTube and search for this course number, you'll find the YouTube channel that I put up. There's 7-ish, 8-ish videos that students submitted. The videos weren't mandatory, but many students chose to edit videos, so some of them were really nice. And so the grade will be computed approximately something like 15% of class participation, like did you show up, did you participate, did you ask questions, and then the rest will be split between the weekly assignments and the class project. So the project has a pretty major effect in one whack, and you'll have 4 or 5 weeks to complete the project. And one of the things that I want to do this year differently is I want to encourage you to start thinking about the project now rather than later. So I may, after we get done the things that I want to cover in the clinic section, I may pull up some more videos and show you some posters from other projects. And I'll tell you about some things that people did, and I'll tell you also about some of the projects that people didn't do that I think are cool. And if there's a project if you're a master's student or a PhD student, or even just an undergrad or grad student who's doing research in a lab, if there's a project that's relevant to the research that you're doing in a lab that might be appropriate for this course, then that's great. It's not double dipping. It means that you're actually doing something that will lead to good research. And so if you think If you have any ideas or you have any questions, please talk to me, and I'll be happy to give you some feedback. Any other questions? Yes.
Where did you say that there was a typo in that assignment?
The day or date. I think the date is wrong.
Because if you're talking about your website, it says Tuesday, February 6th and Tuesday the 6th.
It is. Okay.
I didn't know if it was posted elsewhere.
Nope. I don't think I posted it anywhere else. Assignment due for Tuesday, February 6th. So February 6th, is that correct? You want to see my calendar? Yeah, so it's 6. Okay.
I'd be looking at the webpage from last year.
You might be looking at the webpage for last year. Take a look at on the webpage from last year. I think I put a warning. Go right up to the top. From last year. I like to keep those up so that I can look back and introspect into what we did. Thank you. Is everybody up and running with Ubuntu? Just a personal rant. I ranted a little bit on the website. I find the Unity desktop to be immense and despise it. But the Ubuntu distribution is a good distribution. It does clean installs. And so what I usually do when I install is I install the Ubuntu distribution, and then I install the Ubuntu desktop afterwards. And I read the commands such as navigate install to install a different desktop. And log out, select a different desktop environment, and log back in. Has anybody looked at any of the screen capture videos from when I last gave a short course? Yeah, I'm not sure if they're going to be useful or not. I forgot at the beginning of last class to start doing screen capture. I'm doing screen capture now of these two screens. And the reason for that is it was suggested by some students at the end of last year. They said, sometimes you do stuff in class, you demonstrate something, and you type in some cryptic Linux commands, and damn, I can't get it down, but I'd love to be able to go back in time and just see what that command was. So I'm going to try for a few weeks doing screen capture, and I'll push those up to a YouTube channel, and I'll send out a link, and I'd like some feedback as to whether that's at all useful. Now, the production values are not going to be great because I'm just screen capturing, right? And I have no video producer in order to clean things up. So I'd appreciate some feedback on things. All right. So the web page is designed to drive everything in the course, and if you want to, if you have time, usually the first week of classes, things are a little bit slow in terms of assignments, and if you want to charge forward, you can charge forward as far as you want. So I've added course grading policy here, which I just described. Weekly assignments due 4:30 Tuesday each week, and the idea was to encourage you to finish things up so that when we move on to the next module, you're done and you're prepared to move on to the next thing. I don't give credit for late assignments, but I do drop the lowest score. So week 1 module is overview and course description. We did that. I gave you an overview of the robot operating system and sort of what it does for you, and did some demonstrations. The thing that you're actually going to hand in this week is you're going to write your first ROS package. And for those of you who have taken, since you've all taken algorithms or robot devices, you've worked with ROS packages. And as I understand it, the way Colin and Leonard are using them is they basically give you a ROS package that drives the UR5. And for example, when you're doing forward kinematics, they give you a package, there's a function, it's like put your code here. And that's great, but that's not real software development. That's putting your code here between the comments. So you're going to create an entire package and the CMake lists, the package manifest, everything, and you're going to run it and you're going to push it to a Git repo so that the TAs and I can take a look at it. Reading, I gave reference to 4 textbooks, 3 of which are available free to you through the library if you're on campus. So read some of the things that I've linked here.
The C++ style guide is useful. There's a Python style guide. The TAs and I are, I'm not sure, I think Tyler is a bit of a Python hacker. My lab is pretty much a C++ shop, and so I prefer you do your assignments in C++. If there's a strong reason that you want to do your assignments in Python, then I won't object, but we'll be less able to help you with subtle problems that you might encounter. If you've used Git but you're not terribly familiar with it, I recommend the Git book online and do the tutorials and examples in these 3 chapters, and you'll be able to fly. And let's see, I have linked and mentioned the Git repository for these assignments. We're going to use the repository gitteach.lcsr.jhu.edu. Don't delay. Log on to that now with your JHead credentials. Once you log on, you'll see that you can't create any projects because your quota is 0 projects. So then email Anton at LCSRIT and ask him to increase your project quota to say 20 or 30. And then you'll be able to push things. And this works just like GitHub, except that it's administered and you can use single sign-on credentials. I haven't been able to convince the IT folks to make their security crazy. And right now this is not visible off campus, so the name won't resolve if you're off campus. So if you're off campus, you need to VPN into campus in order to access this repository. If people are having trouble VPNing in Linux, then I could give a little extra thing after class sometime and show you how to do that.
Is there any way to see what quota currently is? Because I'm able to create a project, but I don't know if it's going to run out.
Oh, I thought the quotas were by default 0, so I'm wrong. Yes.
So I just logged in and I've got all my old projects from Cal's class and semester.
Okay, so they didn't blow them away. So you're still live from last year. So that's good. So let sleeping dogs lie. Just go for it. Go for it. If it won't let you create a project, then you can just email Anton and he'll set you up. So most of you probably already have accounts that are working. The tutorials that I asked you to do are listed right here, and I'll just briefly review those tutorials. Hopefully everybody's got ROS Kinetic installed. If you have any problem. So installing and configuring your ROS environment, that's pretty straightforward. Has anybody had any problems with that? If so, I'll circle back to you in the latter half of class. We talked about last time that we can install additional modules with apt-get, and the new images that I've made for the edumip will work exactly the same. So we're running the exact same version of the operating system. Last year, things were a little bit more rudimentary in terms of ROS support, in terms of Linux support for the edumip. And so I had to do a source install under Debian, but now we've got a true blue Ubuntu install. We looked at the file structure last time. The system files are in opt ROS, and I've got two installations installed here. One of them is Kinetic, and one is ROS2 Beta 3. So ROS2 was released in December, and they call it beta, but it's really alpha. And ROS2 brings in a number of new features, and it's probably going to be about a year before it's terrifically useful. It's very unstable right now, and it's not fully functional. For me, I think one of the things that's most useful about ROS2 is that they're using a different transport layer for the topics and services, and you'll have more granular control over bandwidth. So if you have high bandwidth topics and low bandwidth topics, and you have fixed finite bandwidth to push things, say, across a wireless Ethernet to your mobile robot, you'll have finer grained control over what makes it over the link. And in my work, we go everywhere from gigabit Ethernet and 10 gigabit fiber to acoustic modems that transmit 64 byte data packets. and they only travel 1,500 meters per second because that's how fast sound goes underwater. So there's a wide range of transport mechanisms. So ROS-PAC, find ROS CPP. That'll tell you where ROS CPP is. And ROS CD. Let's see, I want to go to the installed package Joy, and this will bring me to the directory for Joy. And if I type ROS CD by itself, ROS CD by itself, it'll bring me into my workspace. And so my workspace is here, ROS CAC and workspace. The source directory is where all my source lives. And I can create a ROS workspace anywhere. Let me think. CD make, ROS CD. And we skipped over in the installation that in the previous tutorial, I skipped over the fact that we need to source the opt ROS kinetic setup .bash in order to get my environment variable set up. And if I have local workspace, then I need to source devel ROS CAC and workspace devel setup.bash. And then we can see the ROS environment variables that we set up by doing that. ROS root is where the version of ROS that I'm using is installed. You can switch between different ROS versions by just sourcing the appropriate setup.bash. And by sourcing those two files, the first of the file that I sourced set ROS package path to look in the system directory opt ROS kinetic share. And the second one, when I sourced the setup.bash from my local workspace, then it put this path here. So when I look for a package, the first place it's going to look in my workspace. If it doesn't find it, then it's going to go on working here. And that's a development pattern that works really nicely. So suppose I have this, there's a system-defined joystick package, which is living in opt ROS, and I don't like that package. I want to hack it. I can download the source code for that package into my local workspace, and I can modify the code. And since the package path is going to be searched locally first, when I start hacking the package, then that's the one I'm going to run. And when I delete that package from my local workspace, then I'll go back to be using the system package. And so this is a notion in ROS called Workspace Overlay. And you can actually have multiple, there's some occasional cases where you want 3 or 4 workspaces that are each overlaid on top of each other when you're doing development. Usually you don't do more than one overlay. We'll talk about ROS master and ROS IP in a little bit. And this is the distribution. So there we are. Every once in a while, ROS CD and ROS PAC screw up, and they haven't refreshed their cache. In which case, if you do ROS CD and you don't get to where you think you should be, you can force rebuilding of the cache by saying ROS PAC profile, and that climbs through the entire tree and it rebuilds the cache for packages. And that cache is also used for tab completion in package names. And so normally when you type tab the second time, it should rebuild the cache, and that's why there's sort of a second hesitation when you hit the tab the second time. So examples here in the tutorial, ROS CD. And then you're going to create a package. And so we can create a package here. Actually, we need to create a guess in the previous tutorial you created a Catkin workspace. So we can create a, if you don't already have one, you can create a Catkin workspace, and you can do make dir minus p my so I'm just going to create a directory called my Catkin, my own Catkin workspace, and it's going to have one subdirectory, source, my own, and then I'm going to type Catkin make, and CMake is going to initialize the workspace, and it's looking for different libraries that we have, whether we have pthreads. It's looking for all that POSIX stuff. And then when we're done creating the workspace, it's created a source direct. It's created a build and a devel directory. And in the source directory, it's created a symbolic link called cmakelist.txt, which points to Opteros kinetic share Catkin CMake top-level.cmake. So it's the top-level CMake file, the default CMake file for a workspace. And now I can create packages in this workspace, but I'm going to create Catkin packages in the workspace that I normally work in for this course. So this is the workspace that I normally work in for this course, Ross Catkin workspace. Let's see what I've got in here. I've got a bunch of different packages and the link for cmakelist.txt. And when I do Catkin make, it's going to scroll through all the packages and it sees that they're all built, so not much happens. R build devel. Build and devel are ephemeral directories with the build is where the compilation products are and devel is where the compilation results are. And so I'm free to remove those. And if then I type Catkin make, it's going to look at all the packages that are in the source directory. And most of the packages you're going to be working with initially, the package is the first level below the source directory. And some of the packages that you'll download actually have several levels of packages. So they're a meta package. You'll download a project that has several packages in second or third levels down. So occasionally you get this, and what's going on here is we've got a failed link. Right now, Catkin make is it knows that my PC. If you don't have htop loaded, load htop with apt-get install. You can see that my PC has 4 hyperthreads running. So it's a 2-core machine that mimics 4 hyperthreads. And so by default, Catkin is going to run as many threads in the build as it can. But that means it's running build jobs in parallel. And so it's not keeping track of dependencies carefully. And so what will happen is it'll run 2 jobs which actually should be run sequentially in parallel. And if they finish out of sequence, then you'll have some kind of a clash. And so if you have that, -J1 is going to force Catkin to just use 1 thread. So you can see Catkin is just burning primarily on 1 thread. And then the dependencies will be handled properly. And one of the nice things about the ROS ecosystem is that it's very careful about keeping track of dependencies. And for those of you who have used multiple large open system packages, you know that can just be a nightmare when they all use different build systems. So everything built cleanly here. And if I want to create a package, I can say Catkin create package. So Catkin create workspace. I'm going to make workspace. This is my new package. the name of the package. It's going to depend on ROS CPP, standard messages, sensor, and sensor messages, eigen. That'll be enough. Okay, create package, name of the package, and then the name of all the dependencies that you know ahead of time. And so it's created a directory called my new package. And in that directory, it's created an include directory, a source directory, and two files, package.xml, which specifies dependencies, and a cmakelist.txt, which is a cmakelist file that uses a lot of catkin macros. My new package. There's nothing in the source directory, and in the include directory, rather strangely, there is a subdirectory called my new package, and that's the design pattern. Your header files are not going to go in the include directory; they're going to go in the subdirectory of the include directory with the same name as your package. And the syntax for when you do an include in C will be include quote package name / header file name, and the CMake system will know where to go out in the file system to get that. So the include system in ROS is aware of package names. And when we want to build, we go back up to the top level directory, the workspace make. And there was really nothing to do in that new package, so everything built cleanly. So the tutorials walk you through that, and we can use the command rospack. Depends. So the package that I just created is called my new. What was it called? Oh, no wonder. Sorry. I created this in the wrong spot. Move my new package into source that belongs in the source directory. My mistake. Didn't like eigen. Okay. So I'm going to recreate this package with without depending on eigen. Okay, so we've got a clean build. There wasn't anything to do in that new package. And in the tutorials, they're going to show you the contents of the CMake list and the package.xml. And in this tutorial, they do the package.xml. So cd source my new package. We just created this. And when we did create packages, it created those two files, package.xml. Everybody see that? So the main thing about package.xml, it's a place to put your name and to-do lists, and the business end is down here. You specify what the build tool is and what the dependencies, the package dependencies that you need at compilation time, and the packages that you need available at runtime. So build depends and exec depends, and you can ignore build export depends for now. The ones that are important for us right now are the build depends and exec depends, and generally speaking, those are going to be the same list of things. So compilation dependencies and runtime dependencies, and that's how ROSPAC knows about things. So if I say ROSPAC ROS dep my new rebuild my cache. Doing wrong here. Move this over to where I can see it. Wrong command. Sorry. So ROSPAC depends one my new package will give me the first order dependencies of packages that we just created, and so I said it depended on ROS CPP, sensor messages, and standard messages. This is all the C++ utilities, and these are messages, standard messages that we looked at last time. And if we say ROSPAC depends, then it will go down the tree of dependencies and it'll tell us all the dependencies, second and third and so on order dependencies. And so these are all the packages, if you descend the dependency tree, of all the things that that it is required to make this new package. Package dependencies are handled nicely. Build our ROS package, we just did that. Cat can make. We saw the compilation commands, and we saw the directories that were created, the ephemeral directories. And requisites. Last time we looked at ROS core. You can run ROS core on the command line. Later on, we're going to use launch files, which will launch multiple different ROS nodes simultaneously. And when you use a launch file, it will check to see whether ROS core is running. And if no ROS core is running, it will run one automatically. And ROS run is how to run a single package without any using ROS launch and on the command line. And so you're going to run this Turtlebot simulation using the ROS run command. So ROS run Turtlebot turtle sim node. I'm going to run a ROS core. No wonder. Okay. It was unhappy because I was on the wrong network. Okay, so I've got a ROS core running in this window. And I'm going to run the Turtlebot simulation here. There's the Turtlebot simulation. And we looked at nodes last time. So somebody's running RQT, the RQT GUI Python on the network, and that's great. And the ones that I'm running here are ROS core, which is listed as ROS out, and TurtleSim. And we can look at RQT graph. It's not going to be terribly interesting right now. Right now there's only one thing, nothing's connected to it. And ROS node ping will ping the node. And then we can run, in a new window, we're going to run a node which sends commands to the turtle simulation right here. So in this command window, there's the TurtleSim node back up. And this node is going to read keystrokes, and it's going to publish twist messages and send them to the simulation. And so hit the keystroke, left key, up key, right key. And if I open up a terminal and I introspect into the topics, there's a namespace turtle1, and command velocity is the topic that's being sent from this ROS node, which reads the keyboard and publishes a twist to that simulation. And if I look at RQT graph, then this is the keyboard thing that's publishing a twist on command velocity, and it's being read by the TurtleSim. And we can look at ROS topic echo turtle1 command velocity. And when I put this, when I bring that back into the foreground, when I hit the up key, then whoops, it crashed. Somebody ran. What happens if you run two nodes of the same name? Then you take over and you bring down my node. That's okay, as long as you know what's going on. So if you run, somebody on the network, so somebody just ran that command and it killed me. But so whoever has command, you can type keys and you can drive the turtle around. So, all right. So So you're going to do this and experiment with ROS topics and introspect, use ROS topics, look at the things you're seeing, and you'll eventually see an RQT display that looks like this. This is the keyboard thing that's generating twist commands, and the turtle simulation is over here. The names aren't quite right here in the documentation, and this is a ROS topic echo process. So you do that, screw around with that, and then you do a little bit with services. You can command, you can send topic commands on the command line, and there's some examples here of how to do that. So you can directly type a command line, which will publish a message either once or repeatedly, and you do that in simulation. You'll spawn, use services to spawn an additional turtle, and then you can have multiple turtles driving around. RQT plot is a crappy plotting utility for plotting scalar values as a function of time. I find it to be tedious and not very useful. There's a tutorial on services and parameters, which I won't go into very much. I think the tutorial is good. Parameters is where you store information like IP addresses and port numbers and serial port numbers and things like that that you want to be configurable. RQT console is not very useful utility that you're going to use. It looks like this, and it lets you introspect into the informational logging messages as well as the warning and error messages that are published in the normal ROS error stream. I don't really find it terribly useful, but the tutorial will walk you through it and give you an example. And so, for example, when you run the turtle into the wall, it's going to generate a warning message, and you'll see it on this console. And ROS launch, you specify a package name and a XML file name. An XML file, by convention, it's called something.launch, and it will launch multiple ROS nodes, and it'll launch a ROS core if needed. This is the format of a launch file. So this turtle sim ran a turtle sim node, and actually runs two turtle sims in two different namespaces. So the nodes are in a namespace, and the topics are in a namespace as well. And they walk you through the launch file, and then you do it. You launch two turtle sims, and look at the topics and how things are being published from the two of those things. Editor options for ROS. And then we get into the interesting thing, which is how to create messages and services. And I'll give you an example. ROS CatCan Workspace. Source. So you're going to create a package called Beginner Tutorials. And by convention, the message definitions for custom messages are in the message subdirectory. And so we're going to look in the message subdirectory. I've got one message file. And so this is how you specify a message. You specify a machine-independent data type in 32, in 16, float 64, float 32, and then you give a name to each element, and you can specify arrays and you can specify other things. What ROS will do when you compile this, it'll take this machine-independent specification of a message, and it will create a data structure for C, for Python, and for Lisp, which instantiates this. And it'll make that data structure properly, regardless of whether your operating system is 32-bit or 64-bit, whether your architecture is little endian or big endian. It'll make that data structure properly. And it will also write serialization and deserialization code, which will serialize and deserialize the data into a machine-independent format for transport across the network. So it does quite a bit of heavy lifting for you. And it does that in the form of, it'll generate a header file, which will be ultimately located in the devel directory. It will create that header file ephemerally. And when a program includes that header file, and the syntax with which the program will include it is include a package name and then the name, in this case, capital N, little um.h, because the message definition was num.message. And then we make this work in the CMake lists. So here's my CMake list for this package. And we just add this right here. We'll comment this. We tell it to look for a message definition file called num.messages. And up here, and this is in the tutorial, so you don't have to remember this, we're going to add a dependency to message generation. And that's all you need to do. And the message header files will automatically be generated. So that creates a new message type. And if I go to Ross Catkin Workspace and I say Catkin make, then it's generated those messages. And the next thing you're going to do is you're going to write 2 C programs to use those messages. And in beginners tutorials, that's going to be in the source directory. And so the thing that you're going to create is a talker and a listener. I'm going to and so the Emacs. And so this example publishes a string, and the whole C program is right here. So main is here, and the first thing you do in a ROS program is you initialize ROS, and you tell ROS core the name of your node, and then you create a node handle, which gives you access to ROS services. So the node handle has a lot of functions in it, and you're going to use the advertise method of node handle and say that you're advertising a string message. The name of the topic is called chatter, and you want to buffer up to 1,000 messages. And then the next thing this does is create a timer callback with the create timer method of the node handle. And it says, I'm going to create a callback, and it's going to call back a function every 1/10 of a second. And the name of the function that it's going to call every 1/10 of a second is called timer callback, which is defined up here. And then we block on ROS spin, and the program will block here forever while these things, while this timer is called. And so here's the callback function. By convention, it takes a timer event argument. Here's the name that we specified down below. And what it's going to do, it's just going to create a string that says hello world followed by a number, and then it's going to publish this on the ROS info stream, which is the debugging stream. And here's where we actually publish on a topic. We created an object called chatterpub down in the main. It's declared up here. We initialized it down in the main, and we were going to publish that message. And so when I say ROS run beginner's tutorial, talker is the name of the node, then It failed because I don't have a ROS core running. So I'll run a ROS core. And so it's printing messages out to the info stream, and that's coming out on standard output. If I go over here and I say ROS topic list, you can see chatter is one of the messages, and I'll say ROS topic echo / chatter. And so you can see those are being echoed. That's the topic RQT graph. So the talker is publishing a topic chatter, and I'm listening to it on ROS topic echo. Yes?
Could you show where you set the frequency?
Yes. Right here, when you create the timer object, you stipulate that it's going to be a duration of 0.1 second. And it's going to call this function. And one of the things you need to be careful about is that you need to make sure that this timer function doesn't fall out of scope. And so if I put, this would not work. So why would that not work? Because it goes out of scope immediately, right? It gets allocated, and then once you fall to the next block, it goes out of scope, and so it's deallocated, and so there's no timer callback. Yes.
So what will happen if the callback function takes more than 100 milliseconds in this case?
It's the programmer's responsibility to make sure that things happen, and so what will happen is it'll miss events. And so in practice, callbacks get called sequentially; they don't get called in parallel. And so it's not well documented, but you'll find when you're actually programming, only one callback function or subscription function runs at a time. And that's why when you look at ROS programs, you don't see a whole bunch of semaphores all over the place. You think that since callback functions and subscription functions are accessing common data structures, there should be lots of semaphores guarding them. And the reason that there isn't is the design pattern is that only one callback function or subscription function is actually active at a time. Not well documented, but it's implicit. When you look at ROS code, it's immediately obvious. So how do you subscribe? Listener. So here's the main down here. Main, you call ROSIDent, and you register the name of your node with ROS. You create a node handle, which is this giant Swiss Army knife that has tons of things. And then you subscribe by designating a callback function and the name of a topic that you're going to subscribe to. And your program is going to create a buffer so that if your program is busy and messages get published, then they're going to stack up messages in the buffer. And so by default, I think the default buffer length is like 10, and so this specifies a buffer length of 1,000. And you can afford to be generous because it's dynamic memory allocation. And so I'm going to need to declare a callback function which of this name with the appropriate arguments. And then ROS spin is going to block forever servicing callback functions and timers and anything else that goes on. And when I type Control C or I set ROS OK to no to 0, then spin will fall through and it'll clean up and it'll deallocate everything. So we need a callback function. And chatter, this is the callback function. By definition, it gets an object which is a constant of the type that we declared for the topic. Remember, topics have types, and so the callback function type has to match the topic type. And then you can do whatever you want with this. So this is the message that it's receiving. And every time Talker publishes, and Talker is publishing while we speak, then the listener will subscribe. So ROS topic echo is listening in this window right here. And then here we can say ROS run beginner tutorials, and I'm using tab completion. L listener, tab completion is your friend. And so it's subscribing and it's publishing what it gets on a topic. And if I do RQT graph, then you can see talker is talking on the chatter topic, and I'm subscribing it with the listener node, and this is my ROS topic echo node right here. Yes?
So you said that the code runs sequentially every time. You said that the code runs sequentially every time a callback is called. So if the callback is too long and it does not return, the rest of the messages will just keep on stacking, right?
For the timers? The timers, my recollection is that it just picks up where you left off, and it doesn't stack up the timer messages, is my recollection. So I'd have to double check the documentation to be sure on that. And generally speaking, you want to be careful when you're using timer callbacks that it's your responsibility to make sure that the code that you run is going to complete in time. And a callback is not really a substitute for a thread. So if you really want to have something that's running off to the side doing a big computation, then what you really want to do is you want to launch a thread so that it can just crank away, and then it can sort of report results occasionally. So if you're factoring primes with 10 zillion digits to them, you probably want to launch a separate thread. And all of Boost threads is in ROS. So the standard Boost threads are all available, and that's entirely compatible with this. So for long-running things that are going to take forever, move it off onto a thread. And if you haven't done thread programming, then we'll cover that later on in the semester. The tutorials are very specific, and getting back to the main instructions here, the assignment is to do the tutorials and then write a publisher node that publishes on a topic and a subscriber node that subscribes to a topic. It's okay if you use just the default string example. If you define your own custom message, that's even better. You'll learn more. And when you hand in your code in a project called Beginners Tutorials, optional, you can write, and the tutorials tell you how to do this, you can write a server node and a client node in order to understand how to use services. And so that's not required for the assignment, but it's desirable. And then I want you to push this to the Git repo in a project called Beginner Tutorials. So please don't just use that name for the project. And then email the instructors when you've submitted and share the project with us. Yes?
I have a couple of questions about that. I know that you use LW as your email, but LWindow belongs here.
Yep.
So I try to add, so HomePen is not finding this name. It's not finding S-Pack.1.
Okay. Let's look at that together.
And do you want to be developers on it?
Yes. Yeah. We can just be viewers. Being a viewer is fine. So I'll debug that with you. So any other questions? So this took longer than I expected. I'm sorry about that. What I want to do starting next week is I'll try to keep the presentation portion of the lecture to some fraction of the hour and 15 minutes that we have, and that way there'll be time left over for you to work on things. I took a little longer than I expected to today. And then the second day of the week will hopefully be largely a clinic where you can bring in and you can work on stuff, and I can help you with any questions that you have. So, any questions? Yes?
With the ball that we'll be using, will we have a dependent timer on the ball?
I can't hear you, I'm sorry.
Will the time on the ball be calculated by the ball itself, or will it be the timer that we have started with on our own machine? So when we SSH into the machine,
When you SSH into
the robot,
into
into the robot.
Turtlebot?
Yeah. So
Yeah. You're not doing that this week.
Oh,
Yeah. So we're not going to use the Turtlebots this week. You're going to do all these assignments on your laptops. And so this week and next week's assignments are on your laptop. We get the Turtlebots for the following week. To answer your question, once you start programming multiple machines, if you don't know how to do it, I'll show you how to set up NTP. And we'll be running NTP on the Turtlebot on your machine, so it's kind of synchronized to the rule set. It doesn't matter what time zone you have your PC set to. Everything, ROS-back is always logging ETC. Any questions? Yes? Yeah, and I just took delivery on Monday of 30 more robots. And so, probably starting next week, and we're inventorying the old ones, so probably starting next week, I'll hand out the robots, so if you want to sort of be working on them on the side, you can do that. We're going to put together little kits. We have about 10 or 15 robots that survived last semester, and so I bought, we've got about 40 students, maybe a few fewer, and so I just bought 30 more robots. And so most of you are going to have to build a robot, but it's pretty easy. You have to solder 2 wires each on 2 motors. Nothing else requires any particular technical skill. And I have made pre-built Linux images for the systems, and I tested those last weekend. But I'll post those probably this weekend, so everything will be up by this week. Any questions? All right, go for it. And I'll be sticking around for a little while so I can answer any questions you have.